This is my last video in my module on frequency distributions, in which we are going to construct our very own grouped frequency distribution from scratch. So let's go ahead and get started. Number 5 here, I say, well, the following data represent GMAT scores for the top 30 ranked graduate business schools. They are listed below, okay? So, I do kind of spill the beans that there are 30 data here. We could write that, actually, now we say n equals 30. Remember, n equals the number of data, or number for n. But we also could have counted this. It looks like we have 6 columns and 5 rows. We say 6 by 5 is 30. But let's go ahead and start with this. When you make a frequency distribution, I'll make this kind of larger so that we can kind of exaggerate it a little bit here. But we always want to start with the class limits. So the first goal that we have in mind here is to come up with our classes. And this is all going to depend upon a couple things. First of all, what the smallest datum is and what the largest datum is. So what they are. So we say 636 here looks like the smallest to me. Now I can't make you a promise, but I tend to do this with my students a lot. I'll put the min and max near the corners here so you can look for them. But we say 636 looks to be our minimum value here. We need to find our maximum value. So we say 718. Do I see anything higher than 718? It doesn't look like I'm seeing anything higher than 718. So this is the top right corner here, or top left, sorry, my other right. But this is our maximum. The first thing we need to determine is, what our classes are. So we're going to start with this. We say range. Recall that range is the same thing as a capital R here. We'd say it'd be the same thing as 718 minus 636. So we'll get our calculator out here. We say 718 minus 636. That's 82. So we have a span of 82. So now this is important to us because what we want to do is we want to create, somewhere between 5 and 20 classes. So now I think that, maybe we try 6 here and we say 82, 6 classes. We did 6 classes in my last video, so we say width. Recall that the width is the same thing as our range divided by number of classes. Okay, so we have this here as 82 divided by 6. Let me bring this over a little bit more here. We say 82 divided by 6 is approximately. So we will need a calculator again here. 82 divided by 6. Now one thing I want to bring up here is this. We should always round this number up. And so we're going to say it's approximately 14. I would have something wrong with this. And there's nothing wrong with the number itself. It's just that this is even. And we want odd, okay? So we don't want even things. So if that's the case, then what we'll do is we'll go back, we'll change the number of classes. If 6 classes doesn't work, then hey, you know what, we'll do 7. And so 7 can't hurt. Let's check this first. We'll get our calculator out again. We say, well, I need to span 82 units in 7 different groups. Each group should have about, well, rounding this up, we get 11.7 here, we get 12. So you know what, it doesn't look like 7 classes is gonna work for us very well. So we try 8. 82 8 ways. So we have 82 divided by 8. We have 10.25. This would give us a class width of 11. So I'm actually going to run with this class width here. We say this is approximately 11. So what this means is we're going to have 8 classes, and we are starting at the minimum. So now the minimum, this is always true. You always start with the min. You may not always end with the max. That happened in our last example. That was kind of cool, but it's not going to happen here. So we say starting at 636. Now, since our class width is 11, we're just going to keep adding 11 onto this to get the next lower class boundary, or lower class limit. So if I added 11 to this, I'd have 647. The next one would be 658. The next one would be 669. The next one would be 680 if you add 11 to 669. If you add another 11 to this, we have 691. Another 11 to this, it'd be 702. So this is, let's see, 1, 2, 3, 4, 5, 6, 7 classes. We need one more, so we say 7. And adding 11 to this, we have 713. Okay, so now these are all of our lower class limits. The nice thing about having your lower class limits settled and in stone there is all your upper class limits are 1 less than the lower class limit for the next class. So for example, the 647 here tells me this top one here will be 646. We say 646, this would be 657. This would be 668. We have 679, 690, 701. 712. And so now this last one, this is kind of tricky. People like to add 11 to this. We say, well, I'll add 11. Remember, this doesn't work that way. We want to add 11 to this guy. So we say plus 11. So if I add 11 to this, I get 700. And let's see, it'd be 23. And so we notice this is not the max, and that's okay. But what I will tell you is this: all of our classes have widths of 11, and we've gone past our maximum, which was 718, which is totally fine with me. So this is our column A here. We need column B, and column B is appropriate B here because we want the class boundaries. Now, I am painfully going to make all of these class boundaries. I'm going to try to make them as quickly as possible with good handwriting. But here's how we come up with the class boundaries. Basically, you take your original data points here, like 636. So the lower class limit, we'll shave a half off of that. So 636, this becomes 635.5. And this is up to but not including 646.5, where I've tacked a half onto my upper class limit. So you take a half off the lower class limit, you put a half on top of the upper class limit. Thing is that you notice if you took a half off of 647 for this next one, you'd get 646.5, which is the same thing you ended your last class with. And this should happen. They should run up against each other like that so that we have no gap. So 657.5. So this will start at 657.5 up to 668.5, 668.5 up to 679.5, 679.5 up to 690.5, 690.5 up to 701.5. Then we have 701.5 up to 712.5. And then we have, last but not least, here, let me kind of scratch this out so we don't confuse it here. We say 712.5 up to 723.5. So now we can start to fit our data into these classes here. So in order to do this, we're going to come up with two more columns here. We say C and D. C is our tally column, and D is our frequency column. So we say frequency, tally. I'm going to use a lowercase f for that. And then we'll do our cumulative frequency last, okay? As far as the tally goes, we'll go ahead and look at class limits to do this. You tend not to use like class boundaries, but we need the class limits to do this. So let's go ahead and get the GMAT scores rocking here. We say 718. 718 would fit into, say, this last class down here. So we put a tally down here. I'm going to put it right there. We'd cross it off. We see 718, 703, and 703, and 703. Each of those would fit, it seems, in the 702 to 712 class. So we say 1, 2, 3, 700. 700 fits in this class right here between 691 and 701. 690. 690 is going to fit in this class here. 695. 695 fits in this class here. 705. 705 is still kind of down here towards the end right there. 705. 690. 690 we've seen before is right here. 688 also goes in the same class that 690 did. 676. 676 here we have is in this class here. 681 is our next datum, which goes here. I'll go ahead and cross it off. So you see I'm crossing things off as I go, which is a good plan. 689. 689 would fit here. 686. 686 would fit here. 691. 691 fits in this next category there, class there. 669. 669 would fit right here. 674. 674 is right here. 652 is my next one, which would fit here. Ooh, kind of a lower one. 652. 680 up next on the docket. We have another one in this class. 670 was, somewhere right around it. We say right below it here. 670. Two 651s. So 651 would fit in this class here, so we have two of those. 637 is quite low. It is in this bottom class. 662 is our next one. 662 fits in this class right here. And in the last row, we say 641 is kind of small. It is in the first class. 645 is also in the first class. 645 again in the first class there. 642 in the first class. And then 660. 660 is kind of more intermediate here. 660. And then last but not least, 636. Okay, so that's, God, the fun part's over. You can see, putting your tallies, lining them up on the left is nice because you can see where the tallies kind of stack. But for frequencies, you just say I have 6 here, 3 here, 2 here, 4 here. Looks like 7 here, 3 here, 4 here, and 1 here. And the only thing I want to bring up is if you were to put a running count on all this, you should get all 30 graduate, GMAT scores. So I have 6 plus 3 is 9, plus 2 is 11, 11 plus 4 is 15, 22, 22 plus 3 is 25, 25 plus 4 is 29, and then this one here would be 30. So cool, we've gotten everything, and then last but not least, we'll put in our cumulative frequency column. So now remember, cumulative frequency. It's like saying the frequencies up until now. So we say, well, how many students had scores 646, the upper class limit there, or below? We'd say, well, I had 6 of them. These are these 6 people right here. But when we get up to how many people have a score up to up to 657 or 657 or below, you could say, well, it's my initial 6 people plus another 3 more now. So if I add them up, I get a total of 9. Okay, so 9. So like we say, well, then this one here was 2 plus the 9 I've already counted. We say is 11. So you're basically just saying this next 11 plus 4 more would be 15. 15 plus 7 more would be 22. 22 plus 3 more would be 25. 25 plus 4 more is 29. Then we have this one here bringing us up to 30, which should always be the same thing as this. So this is how you would create a grouped frequency distribution.